So here's a problem that looks hard at first glance, but requires only second-grade math concepts to solve. Take the pairs of numbers from 1 to n and arrange them in a row such that the 1s have one number between them, the 2s have two numbers between them, etc. For which numbers n is this possible? For example, here's one way to arrange the pairs of numbers from 1 to 3. The 1s have one number between them, the 2s have two, and the 3s have three numbers between them. Notice that reversing the order doesn't change the distance between each pair of numbers, so the mirror image of the solution is also a solution. Now let's try the next case, where we're arranging pairs of numbers from 1 to 4. Feel free to pause the video if you want to try it yourself. So far, both cases are doable. The possibilities are either we haven't encountered a case that's not doable yet, or all cases are doable, and we should look for a common underlying reason for why it always works. Luckily, the case of 1 to 5 is where we run into some problems. If we start with the setup of having 5 spaces between the 5s, then no matter which of the 5 spaces we use for one of the 4s, things don't work out for the other 4 or the rest of the number pairs. The same thing happens with 1 to 6. No matter where we put one of the 5s between the 6s, things just refuse to fall into place. Then 1 to 7 works again. As well as 1 to 8. If we want more cases to consider, then technically the pairs of 1s by itself and the pairs of 1s and 2s are both not doable. So we have a pattern. If we follow this pattern, then the cases of 1 to 9 and 1 to 10 are not possible to arrange in this way. But why does it switch every two numbers? Let's take a closer look at the case of 1 to 5. We have two of each number, so the arrangement is 10 spaces long. If we were to number them from left to right, half of them will be odd spaces, and the rest will be even spaces. Now let's look at the numbers we have. The 2s and the 4s would have an even number of spaces between them, so within each pair, one would always be at an odd space, while the other is at an even space. The 1s, 3s, and 5s have an odd number of spaces between each pair, so each pair is either both at odd places or both at even places. If we tally up these possible combinations, we find that there's no way to arrange all the numbers such that exactly 5 of them are at odd places and 5 of them are at even places. The reason why it switches between possible and impossible every two numbers is because it's only the number of odd number pairs that affect the tally. The even number pairs are already balanced between odd spaces and even spaces. Phew, math makes sense again. Now I wonder if it's always guaranteed to work out if we take an impossible case, say 1 to 6, and remove any odd number pair from it. Also, courtesy of some other Brie on Blue Sky, how do the cases change if we connect the spaces in a loop instead of a row? Let me know what you think in the comments below, and until next time, stay curious.